Welcome to today's Research Pays Off. I'm going to now hand it over to our primary speaker, Zhanping Yu from Michigan Tech University. Take it away.
Hello, hey. I think Emil will be first one.
It'll be nice. Good morning, all. To try to just introduce a little bit the topic here. Make sure my camera is on. And let me just share my screen. I think if I do this and present, you guys should be seeing my screen. Do you see the screen?
Yes.
Yes.
So good morning, all. We wanted to take the opportunity here with this research space off to start, obviously talking about low carbon materials here within our group and NRRA. We have a working group created to work on this topic, and we're looking forward to find the opportunities to meet. And in the meantime, we're looking into defining how this group will look like and what are the things that we would like to accomplish and do. Especially, we're kind of waiting for more information on our low carbon transportation material, and I wanted to take some time here just to explain what are we in Minnesota and why a project like the one Zhanping Yu is doing for us, Dr. Yu is doing for us, is very important as we keep building this program. So in the state, we have a state mandated legislation that requires us to reduce greenhouse gas emission at 30% below 2005 levels and up to net zero by 2050. This legislation created a task force, and that task force will provide recommendation for a program to the commissioner by January 15, 2028 for payments. This statute covers materials, eligible materials, which are carbon steel rebar, structural steel concrete, asphalt and asphalt paving mixtures, and also has eligible projects that should be either new construction or reconstruction of 2 or more lane miles of trunk highway. Then we also just recently got awarded with almost 32 million, just shy of 32 million for the FHWA low carbon transportation material grant. We received this announcement in mid-November, so we've been working since with our division office. We met yesterday to kind of get working and signing the agreement so we can start, being able to utilize funds. Funds under this grant should be obligated by September 30 at 2026, sorry, and should be spent by September 30 of 2031. This is part of the IRA program law, and it provides funding for the use of construction material that have substantially lower greenhouse gas emissions. Now, when it comes to what eligible projects and material are under this, there's federal. It's the projects under Title 23 USC, so Federal Highway 8 and Tribal Transportation Facility, Federal Lands and Transportation Facility, and Access Transportation Facilities from federal lands. And materials covered under these grants are concrete and cement, glass, asphalt, and steel. So we put together a proposal that we submitted during the request for application with this 10 tasks. We're looking right now at preparing an internal survey and an external survey to conduct with our partners to kind of engage industry on how, what's the knowledge, the level of knowledge and the level of effort that has been put into EPDs and obtaining EPDs. We're also going to be looking internal at training, how that training is going to look like. We don't know necessarily yet, but we know there's a lot of others, DOTs and partners interested in collaborating in this. We're obviously going to be looking at EPD collection. This is a big part of our grant here and the storage of that information. We're going to be looking at setting threshold with the information we'll collect and defining those substantially low carbon transportation materials and establishing a criteria for incremental incentive and amount based on the eligible construction project. Task 7, we have made a small change there to kind of separate the component of testing and equipment out of the construction. But it maintains pretty much the same in the sense of there would be some money for construction and some money also for equipment there too. We just want to make sure that since the way this is handled in 2 different processes, there's a process development part and a construction part. We want to make sure that our testing equipment is under that process development part. We also then have 3 more tasks, which is the development of green procurement policies and then specifications updates and preparation for the future. I would actually like to kind of stop there and allow Zhanping to take the rest of the time because his research ties very well with this project with what we are going to be doing, how we're going to start shaping our program. So I think this will be a benefit to all of the attendees here. I think that's all I got. Zhanping, if you want to take the screen. Thank you so
Sure.
much for accepting the invitation.
Well, thank you, Emil. And of course, it's really my honor and, to be asked to see if I can make a presentation. This is really still the project in progress as of now. So I hope everything I said is really represent the true facts, but really it's represent what our understanding at Michigan Tech. So what I'm on my screen here, are you able to see my screen first of all?
We can see your
All right.
screen. It's not in
Great.
presentation mode yet, though.
Not yet.
Nope.
Okay, let me redo it. All right, it's now. Is this good now?
Still, no, not yet.
Okay. Okay, let me just stop sharing again and try to share it again. And let's do it. Share.
Do you have a second screen?
No, I only have one. I'll do this. I'll do the entire screen. Then I'm going to open this one. Now it should be okay, I guess. What do you think?
There we go.
All right, wonderful.
Great.
All right, again, it's my honor to be asked to present to them this this topic. It's a project in progress. I'm pleasantly ready to work with a really good group of people, especially a few people really. One is MnDOT's Kurt Turgeon and Emil from Michigan Tech in the past, and currently WAP Sustainability. So it's a really great team to work with. And of course, other than that, we also have a group from Washington State. So Washington State Department of Transportation, along with University of Washington. So basically, we have a really good team to work with. University of Washington team mainly work with WASDOT on their part, and Michigan Tech works with MnDOT. So on our part here. So the topic I'm going to talk about today, I want to really give a really brief outline. So first I will talk about this, the objectives, and then I'll briefly introduce the EPDs, and then we talk about the main life cycle stages for asphalt, even though I put a concrete here also. And then we talk about the emission reduction strategies for each life cycle stages based upon our understanding. And then, of course, we also talk about Michigan Tech's ongoing project with the MnDOT for developing EPDs for paving operations. Especially really we are talking about more on asphalt portions here, because Michigan Tech is another research team led by Dr. Emil Mukherjee, and he has done quite a bit of concrete related work. So my part is really on asphalt part. The objectives. So there are two objectives. One is we are trying to demonstrate the role of different strategies. Of course, it's what's the highlight of the importance of green public procurement effort. So the role of the green public procurement effort in the U.S. Of course, for this case, is trying to enhance environmental performance in construction projects. For us, really asphalt paving projects. And then, of course, the other is utilize EPDs, and so that we can show how the environment product declarations are used to compare and select low carbon materials, focusing on the asphalt, especially for asphalt. Right? We have not really done anything for glass or steel, but really mainly focus on asphalt. Of course, Michigan Tech also has team do the concrete work as well. And then briefly about introduction. To push to enhance environmental quality and reduce emission has been driving the green public procurement effort in the U.S. And also, of course, there is a strong emphasis in using environmental product declaration for construction materials, especially for asphalt and concrete. So in short, of course, environmental product declaration really is EPDs. We are going to talk about in the next few slides here. EPDs serves as standardized tool for presenting life cycle assessment results, LCA results, and the EPDs help to identify areas for improving environmental performance over the entire life cycle stages of construction materials. EPDs can also ensure fair comparison and selection of low carbon materials for construction project nationwide. For our case, for example, really for Minnesota, you can take a look at this small table here, which I get from NAPA. From this one, you can see here just one example. This is part of the EPD for asphalt mix. So we are using the global warming potential here to represent how much really the CO2 emissions come up from this mixture. So for per ton of asphalt mixture, so we are going to produce about 62.78 kilograms equivalents of CO2, which is, that is a parameter we have here. And for the ozone depletion potential, is, there's a number here. Of course, there are other things really being produced, as part of the greenhouse gas emissions. So usually the EPDs really means, a lot of those things, something like this, right? So this is almost like a nutrition impact labels here. A few more examples I'm going to show. Next one is it really is, so earlier on those numbers you saw is only for the product, right? So the product. So when they make the product, the produced product, how much greenhouse gas emission is going to be produced. So that really we usually call from cradle to gate. What that really means is when you produce asphalt mixture, first you need to produce asphalt liquid, and you need to produce aggregates. Of course, maybe there are other additives as well, And so that's we call the raw materials processing. We use A1 to represent it. For the A2, however, that is the transportation of those materials to the asphalt plant. So for example, if your asphalt is from Texas, now you transfer your asphalt from Texas to Minnesota. And the aggregates also, if your project in St. Paul, you have to transport your aggregates, let's say from St. Michael's, right? It's just I just make up those things. So that is a shipping cost. The shipping part of the effort. That A2. A3 is including the asphalt mixture production in the asphalt plant, right? So basically, from the cradle, from nothing, right, to the to a product. So right now you have whatever tons of asphalt mixture that is cradle to gate. That's A3, or if A1, A2, A3. That's so now for the another part of the effort really is going to be A4, A5. The A4 and A5 really is on the construction stage. Really, that means if you have the product ready from asphalt plant, and from asphalt plant then shipped to the construction site, that is A4. And then of course, then you have to do the operation of paving work. That's paving operation. That is called A5. There are other things like B's and C's. All the B's, it pretty much is the use phase, the use of the pavements, and also the maintenance and rehabilitation efforts. So those are all the B. And also for the C is end of life of the pavements. So those are, if we are talking about from the very beginning of the raw material processing, A1, all the way to the end of C4, that is cradle to grave, right? So, so in general, EPDs can be utilized for benchmarking of global warming potential impacts across different phases of product life cycle. For example, this entire life cycle. We produce asphalt, produce aggregate, and then produce asphalt mixture, and then do the paving, get the pavement ready, and they use the pavements and maintenance, rehabilitation, and then the end of the life of the pavements. So the entire life cycle, it's very really great tool to use a benchmark of greenhouse gas emissions. Next few slides, I'm going to briefly introduce each one of those efforts, especially from all the A's, A1, A all the way to A5. A1 to A3, that is cradle to gate, we just saw earlier on. The source of the greenhouse gas emissions in the cradle to gate stages, including the three things as just mentioned here earlier on also. So including the extraction and process of raw materials. So you produce aggregates, produce asphalt, right? That's extraction and process of raw materials, A1. And for most of the cases, A1 is pretty significant. For example, for this example here, A1 is occupying almost 57% of all the CO2 in this product, in this asphalt mixture. And then another one is called A2, which is transportation of raw materials and to the asphalt plant. So when you finish up all those, all the asphalt and aggregates ready, you ship those things to asphalt plant. That A2. For this case, it only takes 5%, right? That's a small one. However, in some cases, A2 can be very, significant if the shipping distance is really far. And then, of course, another one I want to show here is asphalt mix production. So that is A3. So A3 sometimes can be really significant. For example, for this case, is 38%. That's the per ton of asphalt mixture. You generate 38% of all the CO2. For the example, on this case here, you see about 20.5 kilograms. It's pretty significant. That's A1 to A3. And the environmental impact associated with A1 stage of the conventional asphalt mixture are determined by pretty much all the asphalt mix design. For example, in the asphalt mix design, you said, okay, I'm going to use 20% of natural sand, 20% of gravels, and 20% of crushed aggregates, and whatever those materials you have, right? 5% of asphalt. And so that is pretty much determined how much the A1 is, right? That's the, so A2 is really impacted, will play pretty good role. It depends on the availability of aggregates and other mixed ingredients at local levels. Because that is mainly about the transportation, right? That's transportation. So where it is, if you need to ship those materials, that is something we have to consider. A3, however, is talking about the mixing procedures. The mixing produced really controlled by mixing producers and contractors. Really, for our case, it really is an asphalt plant, right? Asphalt plant. So what asphalt plants they're using, what is burn type, what fuels the contractor is using, the producer is using. So that is really is about A3. And a few examples about those impacts, the A1 impacts. You can see this picture here really is a global warming potential intensity factors for different materials. You can see that for the neat binder, for example, here is 570 kilograms equivalency per ton. That's pretty significant number. But if you take a look at SBS higher, and then you talk about the ground tire rubber, which is the waste tire rubber, right? That's one is 80% of that content in asphalt binder. You can see that's 558. But that means tire rubber is a good thing to use because eventually you are going to have lower EPDs. And now you take a look at lime. Lime, however, is really significant. Lime's the greenhouse emission could be really significant. It's easily double what you have using for an asphalt. Other two materials which is really good is one is RAP. RAP is only 0.71. It's a very good, and of course the aggregates also not too bad. Is 1.76 for most of the materials. The reason really lime really be used, of course, in a lot of places. They use lime, for example, in Colorado, they use lime. which is 700 times more than the virgin aggregates, the global warming potential intensity. That's something really we have to consider. So the positive role for RAP is really great, and so you lower the A1 impacts by replacing the both neat binder and aggregates. So of course, the RAP is something really great for asphalt mix design, and the ground tire rubber, so recycled tire rubber is really another one. So you potentially can have lower lower your EPDs. That's A1 impacts. In the A1 impacts, of course, so we usually in asphalt mix design, maybe about 95% by weight are all aggregates, 5% is really only binder. But the contribution to the asphalt, to each of those two really impacts different. So, the per tonnage aggregates, really you only produce like 1.7 kilograms of CO2. But a binder, you produce about 28.7 kilograms for the average numbers we see. So it pretty much flips those numbers here. So it's binder is really has significantly significant CO2 emissions. So significant contribution of binder, right, due to the emissions during the crude oil extraction, transportation, and the crude oil to refineries, and the refinery to operations. So all those process really is going to be have a major contribution to the CO2 emissions, right, to the greenhouse gas emissions. And then the role of additives, that replacing the binder is a key factor for reducing carbon footprint. And in general, and of course, there are a lot of work being done, like NAPA reported 8% of tire rubber in asphalt. All right, so you can reduce the global warming potential, or we can say reduce the CO2 emissions roughly, let's say, from 631 to 616 kilograms. Right, that's of course, this only talking about the A1. Of course, we need to take a look at this number is 8%, right? So we usually right now we do a lot of projects, so we use a way higher tire rubber content. So in Michigan, we use a lot, 10%. We even use 15, 16, 20, 22, 25% of tire rubber. That's another thing. I'm not going to talk too much about the rubber here. What we are trying to really mention here is the ingredients of the materials we use in asphalt, and of course in asphalt mixtures here. A1 impacts. And then another thing we just mentioned earlier on about the RAP. So the role of RAP is really interesting here. So for a given mixed design we have, if there's no RAP, for example, for this case, you can have 30, this number could be 30 kilograms of CO2 equivalency per ton of asphalt mixture, right? If you are using RAP, then this number will be different. So if you are using 20% RAP, so this number will be declined to 24 or so 24 kilograms. If you further increase the RAP percent, let's say 50% RAP, then this number can be like 15.5, which is almost like half of the mixes you are using without RAP. So that is something really great to know. So that if we are going to use low carbon materials in the future, so that's one thing we really can consider. Well, if possible, we can include in RAP or more RAP. So that is the RAP impact for A1. For the A2, so we already mentioned about A2 is transportation of those the materials to the asphalt plant, right? That's so we calculated based upon the combined transportation impact and of aggregates, binder, RAP, and all those ingredients we're using. So it can be significant if the hauling distance increased. So that is something, if we are, purchasing asphalt or aggregates or RAP, from high, long distance, that could not mean maybe your A2 will be pretty high. And of course, A2 can be high, depends on where you are. especially I know in nationwide. So Louisiana and especially Florida get, they don't really have a lot of aggregates, so they have to get their aggregates from Canada, for example, and then you have very high A2 impacts, right? The shipping distance high. Even use the water shipping, it still can be really significant. Of course, Minnesota doesn't have that much of issue, and also Michigan also in pretty good situation too. For the A2 impacts, like I just mentioned here, you see this one is global warming potential using the kilograms of CO2 equivalency per ton of asphalt mix. You can see this is some states, the data we have. Of course, I get this report from NAPA. So you can see Louisiana, Florida is pretty significant, very high, and Louisiana pretty high. So we in Michigan and in Michigan and Minnesota. So in general, those numbers are lower, right? So that's we get some kind of a medium number here, and the Michigan number is pretty much is the some numbers we produced, with a contractor, because some project when we work for them, so we just trying to convince them to use those concepts and input those data. So those numbers are available. We also have some data from Minnesota also. Right, here is there in the A2 impact on transportation. So this is for the A2 the transportation here. So if no wrap is 2.8, but if with wrap, let's say 50% wrap, this number is become 1.9. So wrap can also have very positive impact on A2 emissions, especially with the hauling distance for wrap are shorter than the virgin aggregates. That is going to make a lot of sense. Right, that is the wrap impacts on A2. A3 is a construction. Sorry, not is a mixing in the plant. So the emissions from the on-site fuel consumptions. So let's say the burner is using natural gas or using some heat, some other heating oil, whatever that is. So that is emission from the fuel in the asphalt plant. Those are going to be counted here. And also, if you're using electricity, and then we don't need to consider the upstream electricity production, which is the indirect emissions. We also need to be calculated there. And then the fuel consumption, including the burners, hot heat, oil heaters, on-site generators, operational equipment in the asphalt plant, such as trucks, loaders, and those things need to be accounted in the A3 stage also. And the burner fuel in general, the fuel consumption is the largest contribution in most cases. For example, this graph here shows that almost 77% of all CO2 are generated by the burner, and there are also some other things, like equipment and how much the hot heat heaters, hot oil heaters, electricities. There are some smaller percentage. Burners is a big one. So that really tells us if we improve our burners efficiency, that's potentially we can reduce CO2 emissions. That's A3. And we also want to talk about the A3 here is on this graph here. The A3 impacts vary to a smaller but statistically significant degree across different altitude climate regions. And the recommendation is to develop a threshold that account for climatic variations. We also have some numbers, reference values for Michigan and Minnesota. Here you see, Minnesota, there are 21 projects, in Michigan there are 7. So 20 percentile, 50 percentile, what's the average look like? That is pretty much A3 impacts. So what kind of asphalt plant has been contributing to the greenhouse gas emission. And we also talk about in the production of the materials, we also really need to consider about the warm mix asphalt. So in this in the project we work with MnDOT currently. So we really find one warm mix asphalt project. So I'm going to talk about those things a little bit later. So in general, if hot mix asphalt plant, for example, in the plant operation, if you if you produce 20.5 kilograms CO2 per ton of asphalt mixture, right? So now that is in general, that's one is normal situation. If you use a warm mix asphalt, let's say reduce the temperature by 30 degrees, then the emission will reduce to 18.6 kilograms CO2. And of course, if you can reduce that one further, let's say go down 50 degrees, that's really a lot of differences. You can see here the number becomes 17.3. That's pretty significant reduction in the CO2 emissions. That is warm mix asphalt. That tells us, if possible, if we can introduce warm mix asphalt, so there is really some good things about the greenhouse gas emissions. A4 and A5, we just mentioned earlier on. A4 is mainly the transportation of asphalt mixture from plant to the job site. A4 is, that's A4. A5 is the construction stage. So the operation, the paving operation, roller operation, and it's pretty pure construction, right? Not including the shaping. The construction related to the greenhouse gas emission for asphalt pavements are relatively low in general. Typically, is about 10% or less of the combined A1, A2, A3 numbers. So usually they are small. However, for every single operations, every single transportation for the A4, A5, we still want to really make sure those things can be reduced, so that we can get a better life cycle EPDs smaller. So the fuel consumptions during the transportation of the materials to the job site, right? That's in the A4, and then the fuel consumptions associated with the paving operations will be A5. You see here, even though both are fuel consumptions, but they are different. They should not be combined together. So that's really the A4 is for any transportation, all the trucks, right? So they use the fuel. Those should go A4. But anything like rollers, rollers, pavers, and water trucks, all those things during construction, that fuel consumption should be going to A5. So we also notice that if the shipping distance is long enough, so then that's you will definitely see increase in emissions. That's A4, A5. Of course, I'm going to show you one slide here is the currently Michigan Tech's ongoing project here. We mentioned it earlier on A1, A2, A3, A4, A5, right? So A1, A2, A3 is pretty well known. So that's the currently cradle to gate situation. So people are have really a lot of good handling of those things, and so asphalt plant really they are able to produce those numbers because they know where their material purchased from, where it's come from, and where's the asphalt, where's the aggregates, and what's the transportation distance, how much fuel potentially can be used. And A3 is they know their plant, right? They know their plant. So supposedly A1, A2, A3 can be handled by the plant. A4, A5, that is the focus area where we are trying to do, because we are trying to really including not only cradle to gate, we really want to say what's the cradle to construction, right? So cradle construction, so that's really A4, A5 has been introduced here. And then of course in our work, really we collect data, collect all the data. I'm going to show you the data just a little bit later, and then use the life cycle assessment and EPD tool, to understand this data, and potentially we can have some benchmarking evaluations. So in the current project we are doing, we are going to use LCA and EPD tool to explore a strategy to measure and reduce the carbon footprint. So of course the goal is still the same. We are trying to reduce CO2, and then we have been working with MnDOT and industry partners really in the past year or so. And pleasantly, we got a really big support from MnDOT, and we also got a really good support from the contractors and the WAPA. So actually MAPA, I said sorry, so MAPA. So I really got the really good support with a group, and so eventually we are also planning the training. So almost tied in with the project for the low carbon construction material program. So provide the training on the carbon emissions measurement and reductions. We also are trying to use LCA tool, LCA data on all the MnDOT projects we are going to be collected. So we collect all those A4, A5 data, of course, in addition on their A1, A2, A3 data. And then we are going to use the tools to integrate together. Our goal is to at least give a first shot to see how really we can generate a potential procurement or specifications, so that we have a good handling on the goal of decarbonization. Of course, I know this, for the project we are doing currently, this goal seems like really big, but we are trying to achieve a small one first. The project selection, in the project we are working on currently, we have really made a short list of 14 projects, 12 projects from MnDOT, and one project is warm mix asphalt project in city of Minneapolis, and another project is a hot rubber chip seal project, being funded by National Road Research Alliance, of course, plus Michigan DOT. So I'm great to work with this partner here. It's really good to work with the city of Minneapolis also, and also MnDOT and also NRRA on the project about the chip seal work. For all the projects we have here, the longest length of projects are 24 miles long, and the highest tonnage of asphalt mix was 107,000 tons. A smaller project would be about 2 miles or so. So we eliminated all the project from the pole which are less than 2 miles. So we don't need to, currently we don't want to study those things too much. So that's the project selection. And of course, the other thing is a selection of the project. We consider, the location, the north region, south, metro region, different locations, and contractors. We also trying to use different contractors just to make sure, we have a good representative. In the on this picture here, the project selection here, you see, on the first column, big column here, this is pretty much the available EPDs, right? That's the cradle to gate, which is including A1, A2, A3. And another one, so we are going to do is called what is a gap? We are really need to look for the construction stage, what's happening here. So really including A4 and A5. Again, A4 is transportation, and A5 is the paving operation, or we call it installation. In the A5, there are a few things really we want to keep in mind. Was we want to really understand what's the pay items, and the contractor practices, regional practices, project size, and scale, and specialty mixes, or any other things like work zone concessions, all those things. So that is project selection. A few examples of the project we visited, I want to show you briefly. For example, for this project here, this is NRRA's and MnDOT supported project. This was constructed in Bay County. Is on the M25. So whatever equipment we are using here, like an asphalt distributor, and rollers, and all those the truckings, everything being monitored to understand the construction stage. So especially A4 and A5. And then another project, this one is a city project in Minneapolis. So the city project is, we find out it's different compared to a highway project, because this one has a lot of corners, a lot of turns, and the construction usually is not as fast as we see in highway operations. But that's another project we have interest. Of course, the other one is because this one has warm mix asphalt. This is the only warm mix asphalt we can see from the pole. One project, the Highway 26. 26, of course, we see this is another interesting project. And also Highway 65. This is a night paving work. I think I'm, like I said here, the Greg Johnson has been really helpful to bring us to the site. We want to really see, what equipment they are using. Are they using, of course, trucks, all right? 20 trucks, 30 trucks, how many runs of trips, and construction equipment, rollers, pavers, and of course, this one also including the mailing machines, right? So water trucks. So all the operations, we really want to, collect the data. And this one is also Highway 65. So some examples about the data we collected. So we have each category, each of the equipment we have data. For example, pavers, rollers, and the water trucks. We all have those data. For example, for pavers, the pavers from this project, for example, if there's one pavers or two pavers, let's assume it's one paver only, like this one, right, from Caterpillar. So this project, this one, in the power equipment, that's 230 horsepower. What's the operation speed? On average, about 36 a foot per minute. It's using diesels. The fuel consumption is roughly about 7 miles per gallon. And then we want to know how many hours this equipment can be operating every day. All right, let's see, today's 10 hours, right? And then total operation days, let's assume it's a 12 days, of course, for each project. We interview with contractors. We also go to the site to check things. So, let's say 70 is a 70 gallon per day of diesel here for this equipment. And then the total fuel consumption for the project will be 840 gallons, right, for the 12-day operations. So that's a paver. For rollers, for example, I give two numbers here. The power of the equipment, 156 horsepower, and you are using about 6 gallons per hour of diesel for the roller. Okay, one of rollers. Okay, so of course on the given project there are multiple rollers around. And A4 impacts. I'm going to briefly talk about the A4 impacts. So A4 really is about transportation, right? Like we just mentioned. In A4, the transportation really means the transportation from the asphalt plant to the job site, right? That is depends on where you are. If the project is really close to the asphalt plant, there are a lot of advantages. The short distance always is desired, is recommended to reduce the carbon footprint. I have one picture here to show that the three projects, we just pick three projects here, just shown on the screen here. One project is 11 miles away, and the other project is 30 miles away, and then there's one 6.6 miles away. You can see on the what we have here is we calculate per lane mile, all right, per lane mile, how much CO2 emissions we may have. Let's see for the 11 miles, distance. So the shipping cost here is about 1,000 kilograms of CO2 per lane mile. And for the 30 miles away, that one is about 2,700 kilograms of CO2 per lane mile. Of course, the 6.6 mile, this one is shorter distance. You can see is quite a bit, kind of less, right? Quite less. So really, what really this from this three parts telling us, if everything else is the same, so the shipping distance is the shorter distance, the better, right? So we want to really see the lower CO2 when possible. So that is the A4 impact. For A5, what is A5? A5 really is, the operations, right? Operations, equipment, what rollers, what kind of equipment that are using on the project. So, for a lot of projects, for example, we have 12.5 non-wear materials, one paver, two rollers, one skid reloaders, one water trucks, okay? So, of course, is there another project? Hey, we have not only one paver, we have one MTVs, the three rollers, and one tech distributor truck. And so there are additional equipment. Of course, you can see this project here. Not on this one is a wear layer also, one MTV, three rollers, and so pretty much same like the project we saw earlier on. But for a lot of project you can see here, oh, there's a pickup broom here, right? So and one sweeper. So some projects that you don't have those additional equipment. Some project has more equipment. So what I'm trying to show here is per lane mile for each of those 5 mixes you see here, their contribution to CO2 emission actually is different. You can see for this material here is, I don't know, maybe it's about 750, right? 750 per lane mile. But for this one here is it's about 1,600, kilograms of CO2 per lane mile. So for each of those things, it could be different. So right now we are still in the understanding of the data, trying to find out a good trend there. So so as I said, it's a still ongoing project, but this is what we are currently at. All right, with with the work ongoing, I think a few conclusions, or I won't really mention here. Increase the use of wrap and recycled materials such as tire rubber may offer an opportunity to reduce greenhouse gas emission by minimizing the need for virgin materials, particularly on A1 stage. Because in all the A1 stages, we already see that there are several materials that you have very high greenhouse gas emission for A1. For example, lime, asphalt. All right, that is something we want to keep in mind. Now, the second one is hauling distance. Hauling distance, especially for A2, can be a really big impact factor due to the unavailability of the raw materials. For example, virgin aggregates. In a lot of some states, the virgin aggregates are far away. It's very hard for them to get it. So that's the reason their A2 can be really significant. And the other thing about the wrap, if the wrap distance is far away, which probably sometimes can be a big issue also. And warm mix asphalt potentially can give you a really good opportunity to lower the production temperature. So because the lower temperature, so then you will save the fuel, right? You save fuel, use less fuel. So basically you cut the greenhouse gas emissions. So that is, of course, in the A3 stages, that'll be smaller. So, I think our goal is trying to reduce, particularly reduce if every single components, A1, A2, A3, if we can reduce those things, eventually you will have a smaller combined EPDs, right? That's the product EPDs. Of course, that's not really something we're talking about A4, A5 yet. A4, A5, we are going to talk about those things a little bit later. So carbon footprint of paving operations usually is low compared to the combined A1, A2, A3 numbers. However, it's a number. It could be 8%, 9%, 10% of the combined A1, A2, A3 stages. So that is still something we should really keep in mind. If we can control that number, that's great. We should do that. Shorter distance of shipping, so from the plant to the job site is highly recommended. That is because shipping distance is lower, so potentially, the trucks use less fuel. So then you definitely are going to, decrease the carbon footprint. That is, regarding the A5, the construction, we still don't really have really a good conclusion yet. That's we are stopping right here. What we are going to do next one is our team is currently still working on the data analysis of maintenance and rehabilitation methods, such as milling, overlay, coating, place recycling. We are trying to really go beyond, the current state of knowledge. We're trying to go forward, trying to see what other approach really we can do. We can find out a good handle of the reduced EPDs in all those stages. We also are going to developing specific potentially threshold and establishing a benchmark for A4, A5 based upon the some of the variations. But of course, this is really a big goal. I know the project Emil just mentioned mentioned earlier on. There will be a lot of things really being developed. So of course, our goal is going to integrate the serviceability based criteria into EPDs to provide a comprehensive analysis of performance, service life, and environmental impact. And we are going to plan a training in February. That's our plan. And that's all I have for now. Again, this is an ongoing project, and it's my honor to talk some of my understanding. Of course, if something is incorrect or anything, please let me know, and we'd be happy to work with you all.
Thank you so much. We do have a number of questions and comments in the chat. I believe a few people had chimed in on some of the answers. So I'll do my best to sort of convey that. We had a question from Tom. Did you contemplate any unintended environmental and human health consequences of increased wrap or crumb tire rubber, which may have non-asphaltic materials in the matrix? For example, the EU has some guidance on this issue, and I believe that Kurt responded that was outside of the scope of this project. And then, yes, and then we have a question from Mike. What is the statistical variability of the GWP values calculated for virgin asphalt binders and GTR modified?
That's a good question. That's something we have to ask NRRA how they calculated. We did not calculate those numbers yet. So
Okay.
the numbers we referenced today are really mainly from the two reports from NRRA. We did not really add any values except A4, A5. That's our numbers.
Okay. And then a question from Raul. Are other assets besides roads going to be considered for this grant project, like foundations and bridges?
That is probably for Emil.
Yes, that's for Emil and Kurt. Yeah.
Okay. And then Ryan asked if this presentation would be available to attendees for further review. And I had commented that the recording will be available at the end of the week. And with your permission, Dr. Yu, we can add a copy of the presentation to our website.
Sure, I have no problem. Of course,
Okay.
the project is the ongoing project. Of course, if the Kurt is okay, I'll let Kurt make that decision.
Okay. And then a question from Tom. And I believe Bernard chimed in with the answer here. Did the study review the impacts of in-place recycling reuse methods? Because the response from Bernard was, we did observe from recent MnRRA test sections that the thermodynamic signatures of the reduced cement content sections differed significantly from those of the control sections. The divergence was more prominent than the ACMs or SCM substitutions, and even more than direct CO2 injection with respect to control sections. Are the actual influence on GWP coherent with our thermodynamic signature observations? So maybe that is a separate question.
Yes, please.
Okay.
I would assume that maybe Kurt is able to answer that question. Is that more like concrete?
Yeah, that's a concrete question, and this project was focused on just
Okay.
A4, A1 through A5 for asphalt. So yeah, it's not outside the scope here.
Okay. So did the study review the impacts of in-place recycling and reuse methods? That would be a question still to be answered.
Yeah, this is you know, something we want to do. You know, also if there are any of those type of projects, you know, ongoing, we'll be happy to collect those data too. You know, trying to understand how really we can handle those. You know, especially A4 and A5 stages of recycling effort.
And the Asphalt Recycling and Reclaiming Association is also trying to pull together data on those processes.
Yeah, thank you, Kurt.
Great. And then a question from Todd. Will you look at the effects of pavement preservation on GWP over the life of the pavement, as in comparing pavements with and without pavement preservation?
That's a really good question.
Yeah,
Okay. And then
the last
I think
answer there is, you know, we're just looking through A1 through A5. When you start looking at pavement performance, you're getting into what's called the B or the use phase. You know, how do you extend the life of the use phase? And then it's your unit would have to be years of service per lane mile or years or easels per year. You know, there's people talking about that, but as of yet, that hasn't. We're just trying to get the basics of getting the road built at this point with this project.
Thanks, Kurt. And then Anna asked, are we looking at implementing a maximum transportation distance of materials to job sites at MnDOT? And I see Kurt responded that we are not looking to limit the distance of materials to the job site. We might have incentives. We might incentivize projects with lower total DWP that would include transport to the project.
Yeah, thank you, Kurt.
Yeah. And then the last question I have here is, what will be used to evaluate project LCAs? Will that be the Minnesota Infrastructure Carbon Estimator?
That's a good question. That's might be a question maybe I should answer. We don't know yet.
Okay.
We might really check that estimator to see how that really can work with you know, for us. But we do have other tools also. There are a lot of tools we potentially can use. You know, this of course could be one of the tools we can put in our candidacy.
And that Minnesota ICE is more of a pre-designed programming level, you know, big round fuzzy numbers versus the kind of detail we're trying to get at here. Mike,
Well, thank you so much for all of the questions and comments. Okay. We are just a minute over time, so I want to wrap things up, but if you have further questions, I believe there's links to email addresses and the project group available. I do have a question here from Jay.
Yes, great presentation, Professor. I really enjoyed it. I applaud you for your use over there on and looking at on the recycled tires, ground tire rubber. I was just wondering real quick, did you get a chance to break down the differences on sustainability between like terminal ground tire rubber and crumb rubber added directly at the plant?
No, well, Jay, it's a really good question. We have not really gone do that part yet. But one good news is that we recently get a grant from EPA to study EPDs of tire rubber. So in next few years, so I think there might be some progress over there.
Great. I look forward to that. Thank
you, Jay.
Thank you all. Thank you for the information and the great discussion and questions. We will wrap it up now and hope to see you in 2025. Have great holidays and a happy new year, and we'll see you next time.
Thank you all.